Okay guys, 2 nights ago we had the experiment that's supposed to be fun but ended up being a bit frustrating. So I thought maybe I should make some commentary videos that can help you to first understand what was the purpose, what was the reason behind the experiment. Second, helps you a little bit with writing the report. At least you know what you're doing, or at least you know what you did. I'm going to start with the prelab. In the last part of the prelab is asking you to find tau. And as I mentioned in the class, the solution that is the common one way of the solutions is that to consider t equals to tau and find that this term becomes 63%, and then find out what would be the 63% of V naught here. This was defined as V naught. And you can find the 63% of that and find what will be the time corresponding to that. That time gonna be your tau. But there was one other common way that was solved in the you use in the prelab, which actually suggested also by Angela in the class, is that you have your input wave, you have your output wave. This is the equation for charging a capacitor. But we know that technically, after you get to the plateau, this is your V in, this is your V out. Your V in should be equal to your V out. So from the picture of the oscilloscope, this one was 10.8 volts. This one was 10 volt. So what you can do is that you can consider V out equals to V in times 1 minus e to the power minus t over tau. And what would be your t in this case? This is your charging period, which is going to be the half of the whole period of the wave, which is going to be your period over 2. Actually, you can read that from the picture that you have, and you can solve for tau. And I guess the tau that you get is, it's just like 1 point something second, I guess, 1.16 second. And the right answer that you can find if you do the 0.63% is like 520 milliseconds, if I remember right. Milliseconds. I could be wrong though. But why don't you get the same answer? Well, the solution that Angela suggested is right in ideal case. What do I mean by ideal? What I mean by ideal, it means that there is no systematic error or no random uncertainty that you can have. In this case, you can see that you reached a plateau, but there's still discrepancy between these two voltages. So even you reach a plateau, you still have the ratio of the V in or V out to be about 97%. So it shows that there is some sort of systematic error in your data. That's the reason that you got the wrong answer. But since your method is right, I give you the opportunity that if you saw this email and now you know why you got the wrong answer, you can email me by Saturday night and tell me that I know what is the right answer, why my answer is wrong. Can you give me the point back? So by sending that email, you show me that you already saw this video. That is good enough for me. So I'm going to give you the point back. But if you do not email me by Saturday night, you're going to lose the point, because it's kind of really important for me to get sure that you spend a few minutes and watch the videos to help you to understand the whole experiment better. Okay, that was the pre-lab part.